Let's take a look at practice quiz number 2, focused on piecewise functions. Number 1 says to graph the piecewise function on the graph to the right, be sure to show the endpoints are open or closed. So I would definitely graph this with Desmos. So let me bring up Desmos and we'll type it in. I'm going to clear everything out and set it back to home so it has a nice normal screen. So I'm going to type negative 2x minus 1. So you want to type this first equation in the first line in Desmos. Don't type all this extra stuff in the front. And then you want to get the curly brace to type in your domain of x is less than or equal to 2. So notice I did not type that comma. You don't need to type that in. So it does look a little different when you type these in. But once you get them typed in, it has a nice graph to look at that you can transfer to your paper. So I'm typing negative x plus 4 in the next row, and then the domain in the curly brace. So x is greater than 2. And then I'm just going to color code mine the way I'm going to write them on my paper real quick. Okay. So I noticed that the first line I've put in my Desmos is blue. And I noticed the endpoint is located at 2, negative 5. So that helps me transfer it to my paper to have a good point. So 2, 1, 2, 3, 4, 5 down. I notice it's got an equal to bar at the 2, so I need to put a solid dot right there. I also notice the y-intercept on that blue graph is located at negative 1. So that would be another good point I could plot in order to draw that line nicely on my graph. Then the red line looks like it has an endpoint at 2, 2, but it would be an open circle. I can tell by looking at my inequality symbol, it's not equal to 2. And then it looks like another good point is this x-intercept over here at 4. So let's put a little dot right there and then just draw that one going off to the left. So in number 1, you're just graphing piecewise. So that's all you would need to do for that one. On number 2, though, it says to use question number 1 to evaluate f of 2 and f of 1. So you can evaluate that with your graph, or you can evaluate it by plugging it in the function. But while I have my graph pulled up, I'm going to do it the graphing way. So I just type in the next row down x equals 2. And just, so it's a different color, I'm going to change it. So where x equals 2, notice I have 2 options, but you've got to notice like which one was solid at 2. So I noticed this one down here is solid, the blue one, and that is where y is equal to negative 5. So that is my best answer to evaluate f of 2. I want the solid dot. All right, then I'm going to type in the 1 for the next one. And I notice this one just touches at negative 3. So there's no question of open or close. You just want to pick out where it touches your graph. Now the other way you can do it is to plug it into the function. So if I want to plug in for this first one, x equals 2, I would want to say which one of these pieces does it belong in? And it belongs in the first piece of my function because that's where it has that equal to bar. And then you just have to plug in 2 for x for that piece of the function. So that would be negative 2 times 2 minus 1, which equals negative 4 minus 1, which notice still gives us negative 5 that we found with the graph. And you do not have to work this out both ways on your quiz. You can choose which way you prefer. But I'm just going to do the other one to show you another example of plugging it into the function. So if I want to plug in x equals 1, then I just have to see which one does that fit with. Is 1 less than or equal to 2, or is 1 greater than 2? So x equals 1 would be less than or equal to 2. And so I have to plug it in that first piece again. So that would be negative 2 times 1 minus 1, which is negative 2 minus 1, which notice still gives us negative 3 that we found on the graph. So that's it for number 1 and number 2. They coordinate, and they will coordinate on your quiz as well. Number 3 says to write the piecewise function that's shown in the graph. So writing it out, we want to think of linear, since these are just lines on my graph. Like linear form is y equals mx plus b. So I've got to figure out the slope, which is our m, which is the rise over the run for our graph, and then b is our y-intercept. So I'm focused on picking those 2 things out of these lines. So I notice this first line right here that I'm coloring with my red pen goes up 1, right 1 to go between the points on the graph. So it looks like it has a slope of 1, and it's positive because it's rising as we look at it from left to right. And then the y-intercept also is touching at 1. So we would say that line is 1x plus 1 when we write it with our slope-intercept form. So then to put it into a piecewise function, we write f of x and a big curly brace, and then we just write x plus 1, and then we want to put the domain for the graph. So I'm going to use my pointer. The domain is just how far it goes because it's not going forever. It's just going between x equals -4 and 1. And then I can also see that these are solid dots right there. So that's important to make a note of. So x is between -4 and 1. I just like to put the left number on the left and the right number on the right. And then put the little symbols that go with those numbers. So it says x is greater than or equal to -4 and x is less than or equal to 1. And it's kind of written between them, just like it looks on the graph. It's between them. And then let's look at this other line over here. So I see this little line over here is going down, and it's going down one box at a time. So it looks like it has a slope of -1. And if it continued to go in that same pattern, it would have a y-intercept of 0. So our equation of that line is -1x plus 0, but we only have to write the negative x. We don't have to write the 1 or the 0. If you do write them, it's okay, but you just don't have to. And then we have to look at our domain, because this graph does not go forever. It just goes from 1 to 3. So it's between those numbers. So put x in between the 1 and the 3, because the 1 is on the left and the 3 is on the right. So write it on your paper in the same order. And then the 1 is an open circle, so just put x is greater than 1. But then 3 is closed, so put x is less than or equal to 3. And then that's it for that one. And you can type that in Desmos and check and make sure that when you type this in, it does look like what's on this graph. So there's a great way you could check your work with Desmos. So let's look at the back page. 4 says in a certain country, income tax is assessed by using the function below, where f of x is the percentage of the income that must be paid as tax, and x is the amount of income. If your income is $12,000, what amount of tax will you pay? So if our income is $12,000, they've said x is the amount of income, so that's important. I'm going to highlight that. X is the amount of income. So notice they've told you that, and your income is $12,000, so you got to look for where is x equal to 12,000 is in this function. So then if I take that and try to see where would it go. So is 12,000 less than or equal to 15,000? Is it between 15,000 and 30,000, or is it greater than 30,000? So I can tell that it goes with my first part of the function where x is less than or equal to 15,000. So then I can tell that I would pay $0 in taxes according to this function. The next question B says if your income is 25,000, so using the same thing we did for part A, now we're just looking at x equals 25,000. So let's move this back over to part A and let's examine part B. So part B says 25,000, so the first one would not be big enough, but the second one would fit because 25,000 is between 15 and 30,000. So if it goes in the second one, it looks like I would pay 12% of 25,000. So we want to put 0.12 times 25,000 because our calculator does not do percent. So you've got to calculate it with a decimal. So let me bring up my calculator to just do the math for that. So 12% of 25,000 is 3,000. So that finishes up part B. And then part C says your income last year was 55,000 and your friend's income was 38,000. How much more did you pay in taxes than your friend? So again, using the same philosophy, it's just a two-part question. So first, let's find what's the taxes for 55,000 and what are the taxes for 38,000. But to find out how much more did you pay, you'll just have to subtract those numbers. So 55,000 is greater than 30,000. So I'm going to pay 18% of my 55,000. So I'm going to calculate that. But 38,000 is also greater than 30,000. So I'm still going to pay 18% of 38,000. So let's just calculate both of those and then we can subtract to figure out the difference. So 0.18 times 55,000 is 9,900 for me. And then my friend is going to pay 18% of 38,000, which is 6,840. And then we just have to subtract 9,900 minus 6,840. So in my calculator, I can just grab those numbers. I don't have to retype. So I don't make a typing error by accident. So then the difference is $3,060. And so that would be how much more I would have to pay in taxes. All right, number 5 asks us to describe some key features of the graph. So let's go over these. Domain is left to right. So I notice this graph's going left forever and ever and ever. And then 1 is included by this solid dot. Everything between 1 and 2 is included, and 2 is included, and then it goes to the right forever. So everything is included from left to right. So we just write that as negative infinity to positive infinity. The range are the y values, and you start with the lowest y value. So I notice this graph is not going down forever. It stops right here, and the lowest y value I see is 0. And then there's no hole in the graph right there, so we need to put a bracket with 0. And then I also notice this graph goes up forever over here, and it continues to go up forever over here. So it's going to go to infinity. So from 0 to infinity is my range, and I need a bracket with the 0 since it's equal to 0. Now let's do increasing, decreasing, and constant together. So I notice if I'm driving along from the left to the right, my little car would go downhill first. So I'm going down and down until I get to x equals 0. So I would say it decreases from negative infinity to 0. And then it turns around right there and starts to go up. So my little car is going uphill until it gets to 1. So we got to say it increases. And I put decrease in the wrong place. Let me move that down. It's increasing from 0 to 1. And we could put a bracket at the 1 since that's the end of that interval. And it's not shared with the next interval. But then I see I have a little flat interval. So that's my constant interval from 1 to 2. So let me grab another color. Let's say from 1 to 2, it's constant. And we could put a bracket at the 2. And then it increases again from 2 to infinity. So that was increasing. My little car is going up again at that point from 2, but it's not equal to 2. So let's put 2 to infinity for increase. And then the constant was this one where my little car didn't go up or down. It just jumped up there and stayed flat. We're pretending. Okay, so positive and negative. Positive is everything above the x-axis, and negative is everything below the x-axis. So I notice in this graph, everything is above the x-axis and nothing is below the x-axis, and that can happen sometimes. So positive would basically be my domain again, because everything in this graph, all the x values were positive. And then negative would be none, because we just don't have anything that sits below the x-axis. So that's none. And then last but not least, let me grab one more color. We have end behavior. So end behavior are the ends of the graph, like the leftmost and rightmost ends of my graph. So I noticed that this end over here is going toward the second quadrant where everything for x is negative because it's going to the left forever. And everything for the y values are positive because it's going to go up forever. So I would say for that end, as x approaches negative infinity, y approaches positive infinity. And then for this other end, it's going toward the first quadrant where everything's positive. So we just have to write that out with the right notation. So as x approaches positive infinity, y approaches positive infinity. All right, so that's it for practice quiz number 2.